Hi, welcome to lesson number 3, module 9 of the Big Data and Hadoop Developer course. So in this particular lesson, we'll be having a look at the Flume architecture. Now before we proceed with the lesson, let's have a quick recap of the previous lesson. So in the previous lesson, we have learned what exactly is Flume and its features and the agent. So in this lesson, we will be breaking down the architecture of Flume into components such as events, agents, client, source, channel, and sink, and we'll be learning about them in detail. So first of all, let's understand what exactly is a Flume event. Because whenever we discuss about Flume, the first component that usually gets referred to is an event. An event is any type of data that can be transported by Flume. So to be precise, an event is defined as the smallest unit of data that can be carried out by Flume. The following illustration depicts the basic architecture of Flume. So if you look at the overall architecture, we have the data generators that can be either a web server or an application server or any type of server from where we want to collect the data. So as shown in the illustration, data generators generate data which gets collected by individual Flume agents running on them. Now thereafter, a data collector, which is also an agent, collects the data from the agent, which is aggregated and pushed into a centralized repository. Now usually what happens, even though the data is getting generated at a particular web server, a Flume agent might not be running there on that particular web server. We will have a Flume client running on them. The agents will be actually running separately from the place where the data is getting generated. So like you can see in this picture, the data generators are separate, such as web server, and the agents are actually running on separate machines. So let's explore them in detail. Now, event is the basic unit of data transported by Flume from source to destination. As explained before, Flume doesn't really care about what is inside an event, and events can have optional headers. So what happens is that in case you're collecting log files, then an event is a single line in a log file entry, because that is the smallest unit of a log file that can be carried by Flume. Or in case if you're collecting Twitter data, then an event might be the generation of a single tweet. Now, optionally, you can have headers in an event which are having unique key value pairs. Now, these headers are used for contextual routing. You can have a header in a Flume event which will mark it with a higher priority, so that using contextual routing you can move that particular event into HBase rather than directly moving into HDFS. However, the header part is completely optional. Now let's understand what exactly is an agent. An agent is an independent daemon process, or JVM, in Flume. Always and always, an agent is defined by at least three components such as source, sink, and channel. Now the agent basically receives the data or events from clients or other agents and forward it to either the final destination or to the other agents. Flume may have more than one agent. Following diagram represents a Flume agent. So what happens is that if you want to run Flume, then you must configure an agent, because an agent is ultimately the daemon which will be running and doing the work for you. So the agent can be configured by editing a text file. It is very simple to create an agent, and an agent always have a source, sink, and channel. Now the idea is that in a very complex Flume workflow environment, you will have more than one agent. So what happens is that an agent can either take data directly from the source, in that case it will be sitting near to the source, or it can take data from another agent, in that case it is in tier 2 or tier 3. And much the same way, the last agent in the chain will store the data to the sink, which is Hadoop itself, or the agent can give the data to another agent if it is configured like a chain. As shown in the diagram, a Flume agent contains three main components: source, sink, and channel. Ultimately, it is a single JVM. Every agent is a single JVM that runs to perform the data collection. So here you can have a look at the detailed architecture of Flume. So on the left hand side we have a web server and there are events. Now we understand what is an event. An event is the smallest unit of data that is generated, and we have something called a client, which we'll be discussing in the next slide. And once the data gets generated, these are being absorbed by the agent. Now the agent has a source, channel, and sink. Source is the part which absorbs the data, and source can place the data into one or more channels. Now the sink will consume the same event from the channel, and then it can commit to a final destination such as HDFS. So let's see what is the role of something called a client. Now the basic idea about a client is that it operates at the point of origin of data and delivers them to a Flume agent. So in a fine design the Flume architecture, you want to decouple the Flume agent from the place where the data is getting generated. For example, you might have a web server where log files are getting generated, and then Flume agent which is sitting on another server. Now the question is that if I have the log files getting generated on the web server, how do I send them to the Flume agent over the network? That is done by this client. Now there are multiple types of clients that are possible, and if you are looking at specifically log files, the most widely used Flume client is the Flume Log4j appender. Now, as we are aware, Log4j is a very popular implementation for log collection, and you can simply edit the Log4j configuration file to have this Log4j Flume appender. What it will do is that as in when the new logs are getting generated, this can append it over the network. And like I explained, this decouples Flume from the system where the data is generated. Now, Flume contains a number of built-in mechanisms to ingest the data. Some developers may want Flume to communicate directly with a custom application. Flume SDK is a library that enables application to connect to Flume and send data to RPC. Now, you can also have, for example, let's say that you are running a specific application in your application server. Now this application generates a lot of data and you want this data to be continuously sent over the network to the Flume agent which is sitting on the next server. How do you do that? You cannot use Log4j appender because it is not a log file, it is application specific data. For that, Flume provides a Flume SDK library which you can customize with your application so that whatever your application is generating, the data can be transferred directly to the Flume agent. A third type of embedded agent is also present, which basically is a Flume agent running on the web server itself. So let's say you don't want to use the Log4j appender, and you also don't want to use the SDK, then the third option is that you can have a embedded client. So what do you mean by an embedded client? It is again a built-in Flume agent which is running on the web server where the data is getting generated. Now this seems to be very easy, and the only drawback of this embedded agent is that there will be a lot of performance overhead since a complete agent is running on the place where the data is getting generated. So, and all this communication happens through RPC, which is remote procedure call. So the communication between the client to the agent is usually through RPC. As of Flume 1.4, Avro is the default RPC protocol. So Flume supports Avro and Thrift, but by default Avro is the default RPC protocol in Flume. Now let's see what you mean by a source. A source is the component that receives events and plays it into one or more channels. Now, like we understand, depending on what kind of data you want to pull, there are different types of sources available. there are predefined sources for Flume. For example, syslog is a type of source which can collect log files. Now you also have something called netcat. With the help of this source, Flume captures whatever you type on the terminal and send it as a bunch of text file. So for example, if you want to capture the terminal of a particular server, I can mention in the Flume agent that the source is netcat. You also have exec and seq. Now seq is a sequence generator, so this will automatically generate data for sequence generation, and exec is also a type of self-generating source. We also have Avro and Thrift, which are basically used for agent-to-agent communication. The key point here is that the source is an entity which can collect the data depending on what type of data you want to collect. For example, if I'm interested in collecting Twitter data, then my source will be Twitter. If I want log, it can be syslog. If I want terminal capture, it can be netcat. And then it can place that into one or more channels. Now, a source always requires a channel because once it receives the data, it places into this channel. A source is a component of agent that receives data and transfer it to one or more channels. Now Avro, Log4j, syslog, HTTP post, there are many sources that are available, even it allows HTTP request. So here we see what exactly is a channel. Well, a channel is a temporary source that receives the event and that buffers till they're consumed by sink. Now you can actually have multiple types of channels. You can have something called a file channel and a memory channel. The default implementation of Flume is to use something called a memory channel, which is the computer's buffer. So whenever the source receives the data, it places into the buffer of the buffer memory of the computer so that the sink can consume it. So it is a temporary queue from where the source can write and the sink can read. However, when you are using the default memory channel, it uses the main memory or the RAM of the computer, and in case the system restarts, then this buffer data will be gone. So that is the case when we use the file channel. When you use the file channel, you can mention a location on the hard disk. It acts like a write-ahead log where these events will be placed, and from there the sink can read. The channel decouple the event input rate from the event output rate. When the event spikes occur that cause data to be generated faster than it can be transported to the destination, the channel size increases. So usually when you configure a Flume agent, you can mention the channel size. So in case of an event spike, more and more events will be consumed by the source, which can be buffered into the channel unless the sink is ready to consume the same. The last part of the component is called a sink. Now a sink stores the data into the destination. Now a sink can either store the data to the final destination such as HDFS or HBase, or it can also store it into another agent. So sink is the part where the buffered data from the source are consumed. So either it can be consumed into HDFS, raw HDFS, or something like HBase or into another agent. So to summarize, in this lesson we have learned the architecture of Flume, and we also learned the individual component and their architecture. That's all for this lesson.